How to understand enlargement of a shape. Understand what enlargement is. Enlargement or dilation is a transformation that changes the size of a shape but keep its shape the same. The key feature of enlargement: the shape gets bigger or smaller depending on the scale factor. If it is a negative scale factor, it's going to be negative. If it is a whole number, it's going to get bigger. If it's a fraction, it's shrink. If it is 0, it doesn't change. All the sides are multiplied by the same scale factor. The shape remains similar with the same angle and proportional sides. Enlargement is done from a fixed point called the center of enlargement. Step 2. Understand how to find scale factor. Scale factor determines how much the shape grows or shrinks. So again, earlier, if the scale factor is greater than 1, it's get bigger. If the scale factor is a fraction or between 0 and 1, the shape gets smaller, reduce, or shrink. If the scale factor is equal to 1, no change. If the scale factor is greater than 0, no, less than 0, the shape is enlarged, flip, or across the center, something like that. Step 3. Ways to enlarge a shape. Some way 1. Enlargement from our origin. If it is from the origin, you multiply each coordinate of the shape by the scale factor. And scale factor is always represented by k. So you multiply the x vertices of A, you're going to do it the same as y, and the answer you get, you plot the new point and draw the enlarged shape. Like for here, enlarge A 2, 3, B 4, 1, C 3, negative 2 by the scale factor 2 about the origin. So here, what they did is to time the scale factor by every point. So for A, they timed the scale factor by 2 and 3 again. So the scale factor, which is 2 times 2, which is 4. The 3 is 6. Same thing for B. The scale factor times 4, you get 8. The scale factor times 1, you get 2. The scale factor times 3, you get 6. And the scale factor by negative 2, you get negative 4. And then you plot the point. That is for the origin. If it is not about the origin, this other approach is for you. Way 2. Enlarge from any given point. First, you find the distance of each point from the center of enlargement. Multiply the distance by the scale factor k. Plot the new point by moving the shape away from the center of enlargement. So when you find the distance, you can either measure or you can use a translation approach, where if you go 2 up from the center and go down to the point, you know the vectors, and it times that by the scale factor. The answer you get, you're going to start from the center of enlargement and do that vectors.
Alright, here's a set of axes and I've drawn a triangle on it here. Now, in order to specify how you do an enlargement, there's a couple of things you need to say. So for any enlargement, in general, first of all, you need to say what the scale factor is. The scale factor is how much bigger it gets, or as I say, possibly smaller. So if the scale factor is 2, that means the triangle is going to get bigger and all the lengths will end up being twice as big. If the scale factor were 3, then all the lengths would end up being 3 times as big. If the scale factor were a half, then all the lengths would end up being half as big. And that's how a triangle or any shape can end up getting smaller with an enlargement. It's a bit of a misleading name, as I say, but the scale factor is the thing that controls it. So a scale factor bigger than 1, that's multiplying it, it's going to get bigger. But if the scale factor is smaller than 1, like a half, it means it's going to get smaller because all the lengths will be half as long. So that's the first thing you need. And the second thing you need to specify is what's known as the centre of enlargement. Now, very often when they give you an enlargement question, they will specify the origin, that's the point where the two axes cross, the 0 on both axes. They'll often specify the origin is the centre of rotation, centre of enlargement. Now, if that's the case, it makes doing the enlargement much easier. And I'm going to show you two different ways of doing this. If the centre of enlargement is the origin, then there's a very quick and easy way to do the enlargement. If it's not the origin, though, you have to go the long way around. There's a more difficult way you have to deal with it. So I'll show you both of these. But before we do that, we need to know the coordinates of the shape. Now, sometimes they won't give you the shape. They'll just give you a set of coordinates. So if we say that our coordinates are going to be 1, 1, 1, 2, and 3, 1. So 1, 1, remember it's x first, y second. So 1 in the x and then 1 in the y, that's the bottom left corner there, that's 1, 1. 1, 2 means 1 to the right and 2 up, so that's the top left corner. And 3, 1, it's 3 in the x, 1 in the y, that means 3 to the right and 1 up. So that's the bottom right corner. So these three coordinates here are the coordinates of the three corners of the shape. Now, if the centre of enlargement is the origin, then whatever the scale factor is, so let's imagine we have a scale factor of 2 for our first one. So everything's going to get twice as big. As long as the centre is the origin, you just times all of your coordinates by the scale factor. So in this case, instead of 1 and 1, you're going to get 2, 2. 1, 2 would become 2, 4, and 3, 1 would become 6, 2. Yeah, each of the numbers has just become twice as big because the scale factor is 2. If the scale factor were 3, they would become all 3 times as big. And then you just plot the points. So we've got 2, 2. So you go to 2, 2. That's going to be 1 point there. 2, 4. 2, 4 is up here. And 6, 2. 6, 2 is going to be here. You join up your 3 points and you get your enlarged triangle. And all the lengths on this triangle will be twice as long as they are on the original triangle because the scale factor is 2. So that's the easy way. You just take the coordinates, times them by the scale factor. And that will work for any shape at all, as long as you know the coordinates of the corners. But only if the centre of enlargement is the origin. Now, if the centre of enlargement is not the origin, you have to use a completely different method. But as I say, most of the time you will find the centre is the origin. So let me show you the other method. Well, I'll leave those coordinates there so we can compare them later. And I'm going to leave the centre of enlargement as the origin, but I'm going to show you the other method so you can compare them. Essentially, what you have to do is, with a ruler, draw a straight line from the origin through each corner of the shape and then off into the distance. So, if we've got one corner here, as I say, you draw a straight line from there, through there, and then whoosh, off into the distance. The same thing with this corner. So from the origin, from the centre of enlargement, through that shape, off into the distance, and then finally through that corner there, more or less like that. So you draw lines through each corner of the shape. So if it's a square, you'll be drawing 4 lines. Because I've got 3 corners, I'm drawing 3 lines. Then with a ruler, you have to measure the distance from your centre of enlargement to each corner of the shape. So let's imagine that you measured from here to here, and it turned out to be 3.2 centimetres. So you do that for all 3, but then whatever that distance is, you have to times that distance by the scale factor. Now you might need to do that on a calculator if the distances aren't working out to be nice whole numbers. In this case, if we times it by 2, you're going to get 6.4. So you then measure 6.4 centimetres from the centre of enlargement again along the line that you've drawn here. If the scale factor is 2, that distance will be twice as far as the original distance. Yeah, because you're timesing it by 2, so it will be twice as far. So obviously I don't have a ruler here, but just roughly speaking, twice the distance is going to put you about there. So again, you'd measure that distance, you double it, which is going to take us to about here. You measure this distance, you double it, which is going to take us to about here. That gives you your 3 points, and then you join them up to make your new enlarged triangle. And if you've done this accurately, then you'll find the coordinates will be exactly the same as if you'd used the other method. So the first one should be at 2, 2. So this point, yeah, 2, 2, 2, 4. So 2, 4. Yeah, that looks good. And then 6, 2. So 6, 2. More or less, that's all right. Obviously, if you do this on graph paper, you can make this very accurate and you'll have your coordinates in exactly the right point. But that's the method you need to use if the center is not the origin. I'll give you another example of this in a second. So you draw your lines to each corner of the shape, measure the distance to each corner, then times it by the scale factor. So if the scale factor is 2, whatever that distance is, you're doubling it, which will take you to here. So whatever that distance is, you're doubling it, which takes you to here. Alright, give me a moment to rub this out. I'll draw another example on, and this time we're going to pick a different centre of enlargement, not the origin. Alright, so I've got a square now, and this time I'm choosing the centre of enlargement to be this point here. So as a coordinate, our centre, I'll write it here, is going to be 4, 0. It's 4 in the x direction and nothing in the y direction. So we go 4 to the right, and then we don't go up or down, nothing in the y direction. So that's where the centre of enlargement is going to be. And if they give you a centre that's not the origin, they'll usually tell you what the centre is as a coordinate. You need to find where it is on your axes and then mark that point. Now, you can't do the thing about doubling the coordinates here. It's not going to work. So the first thing you're going to need to do is through each corner of the shape, you need to draw a straight line. This time I should say the scale factor, I'm not going to use 2, I'm actually going to use a half. So we're going to make the square get smaller this time. So step 1, from the centre of enlargement, straight line through each corner of the shape. So something like that, and you extend it off into the distance. That was that corner. This corner then, like so. This corner, and this corner, more or less. Again, you measure the distance from the centre to the first corner, and you times that distance by the scale factor. So this time, instead of taking that distance and doubling it to here, we're going to take that distance and we're going to halve it. So the new point, the new corner of the square, will end up half of the way to the old corner, the original corner. So in this case, I'll just do this by eye. Half of that distance is going to put you about there. This point from the centre, you measure that distance, times it by a half, you're going to end up about there. This distance, halve it, and then this distance, and halve it, you end up about there. Those are your 4 new points. You join them up, and more or less, you've got a square, which is smaller than the original square. And in fact, all the lengths of this square will be half as big as they were on the original square. The square, this new enlarged, although really it's smaller, square is overlapping the old square, and that can happen. So don't worry if it overlaps the original. It can also just join up, so it ends up touching one of the sides. That's fine as well. It really doesn't matter.
Center of enlargement. To find the center of enlargement is extend the line connecting each original point to its corresponding letter or enlarged point, and these lines will intersect at a center of enlargement. So you pick 2 pair of corresponding points, draw the straight line through each pair. The point where the lines meet is the center of enlargement. Look at this example. So we connect from A to A, straight line, C to C, straight line, B to B. You see, you get right here 6,4. To find the scale factor now, you have to measure the distance. If you measure the distance of BC here and you get 2, and you measure the distance from BC here, you get 4. So the image over the object, and that's how they get a scale factor of 2 right here. Quick tip for mastering enlargement. Use graph paper for accurate scaling. Use a ruler to extend line for finding the center. Practice with different centers and scale factor to build confidence.